In the world of software development, quality is paramount. A high-quality software product not only meets user needs, but also stands the test of time. This is where the FURP model comes in. FURPS stands for functionality, usability, reliability, performance, and supportability. These 5 components represent a comprehensive framework for evaluating and ensuring software quality. The FURP model acts as a guide for software development teams, helping them focus on the key aspects that contribute to a successful product. By considering each element of FURPS throughout the development lifecycle, teams can identify and address potential issues early on, reducing costly rework and delays. This proactive approach leads to higher user satisfaction, increased product adoption, and a stronger competitive edge. In the following sections, we'll delve deeper into each component of the FURP model, exploring its significance and how it contributes to building superior software solutions. By understanding and applying the principles of FURPS, development teams can elevate their software from merely functional to truly exceptional. Functionality sits at the heart of the FURP model. It refers to the core purpose of the software, what it is designed to do. A software product's functionality encompasses all its features and capabilities, ensuring they meet the specified requirements and effectively address the intended user needs. To ensure functionality, developers must clearly understand the project requirements. This involves gathering comprehensive information from stakeholders, including users, business analysts, and product owners. Detailed documentation of these requirements is crucial, serving as a roadmap for the development process. Regular testing throughout the development lifecycle is also vital to validate that the software functions as expected and meets the defined criteria. A common pitfall in software development is scope creep, where new features are continuously added without proper planning or consideration of their impact on other aspects of the project. Therefore, adhering to the defined scope and prioritizing essential features is crucial to delivering a functional and successful product. Consider the example of a simple calculator app. Its core functionality revolves around performing basic arithmetic operations like addition, subtraction, multiplication, and division. While functionality focuses on what the software does, usability addresses how easily users can interact with it. Usability is about creating software that is intuitive, easy to learn, and enjoyable to use. A highly usable software product requires minimal effort from the user, allowing them to accomplish their tasks efficiently and effectively without frustration. Key aspects of usability include the software's user interface, UI design, navigation, and overall user experience, UX. A well-designed UI should be visually appealing, logically organized, and consistent throughout the application. Usability testing is crucial for identifying and addressing potential usability issues. This involves observing real users as they interact with the software, gathering feedback on their experience. By understanding users' needs, pain points, and preferences, developers can make informed design decisions that enhance the software's overall usability. Reliability refers to the software's ability to perform its intended functions consistently and accurately over time. Reliable software is dependable and predictable, operating without errors, crashes, or unexpected behavior. Users should be confident that the software will function as expected, delivering consistent results and maintaining data integrity. To achieve high reliability, developers must employ rigorous testing methods throughout the development process. This includes unit testing, integration testing, system testing, and acceptance testing. These testing phases aim to identify and eliminate bugs, ensuring the software functions correctly under various conditions. Additionally, implementing error handling mechanisms and logging capabilities can help identify and address issues promptly, further enhancing reliability. Software defects can have significant consequences, ranging from minor inconveniences to major disruptions. For example, a bug in a banking application could lead to inaccurate account balances or failed transactions, causing financial losses and damaging customer trust. In contrast, reliable banking software ensures accurate data processing, secure transactions, and consistent performance, instilling confidence in users and safeguarding their financial well-being. Performance centers on the software's speed, responsiveness, and resource consumption. High-performance software operates quickly and efficiently, utilizing system resources such as CPU, memory, and storage. Users expect software to respond promptly to their actions, avoiding delays or lag that can hinder productivity and lead to frustration. Optimizing software performance involves various techniques, including efficient code design, database optimization, and effective memory management. Developers can utilize profiling tools to identify bottlenecks and areas for improvement. Additionally, load testing simulates real-world usage patterns, helping assess the software's performance under different load conditions and identify potential scalability issues. Slow and unresponsive software can negatively impact user experience and productivity. For instance, a sluggish e-commerce website can deter potential customers, leading to lost sales and revenue. Conversely, a fast and responsive website provides a seamless shopping experience, encouraging customers to browse products, make purchases, and return for future transactions. Imagine a video editing software application. Performance is crucial in this scenario, as users expect to edit videos smoothly, apply effects quickly, and render final projects efficiently. Supportability encompasses the software's maintainability, adaptability, and scalability. Maintainable software is easy to understand, modify, and enhance over time. Adaptable software can be easily modified to accommodate changing requirements or integrate with new technologies. Scalable software can handle increasing workloads and user demands without compromising performance. To ensure supportability, developers should prioritize clean code, modular design, and comprehensive documentation. Clean code is easy to read, understand, and modify, while modular design allows for independent components that can be easily updated or replaced without affecting the entire system. Comprehensive documentation provides essential information for future developers, facilitating maintenance and reducing the learning curve. Software that lacks supportability can become a burden to maintain and evolve. For example, poorly documented code with complex interdependencies can make it challenging for developers to understand the software's inner workings, leading to difficulties in fixing bugs or implementing new features. Consider an enterprise resource planning (ERP) system used by a large organization. Supportability is crucial in this scenario, as the software needs to adapt to evolving business requirements, integrate with new systems, and accommodate a growing user base. The FURPS model has been successfully implemented by numerous companies across various industries to enhance their software development processes and deliver high-quality products. Let's look at some real-world examples. Google Search. Google's search engine exemplifies the FURPS model in action. It excels in functionality, providing highly relevant search results based on user queries. Its usability is renowned for its clean interface and intuitive search functionality. Reliability is paramount, ensuring consistent uptime and accurate results. Performance is optimized for speed, delivering search results in milliseconds. Supportability is evident in its ability to handle billions of searches daily and adapt to evolving search algorithms. Amazon.com-Amazon's e-commerce platform showcases the effectiveness of FURPS. Its functionality encompasses a vast product catalog, secure payment processing, and efficient order fulfillment. Usability is prioritized through personalized recommendations, user reviews, and a seamless checkout process. Reliability ensures consistent platform availability and secure transactions. Performance is crucial for handling millions of transactions daily, providing fast page loads and a smooth shopping experience. Supportability is evident in its ability to scale during peak seasons and adapt to changing market demands. These examples highlight how the FURPS model can be applied to different types of software, from consumer-facing applications to enterprise-level systems. Implementing the FURPS model in software development offers numerous benefits, including improved software quality. By addressing all 5 aspects of FURPS, development teams can ensure the software meets high standards of functionality, usability, reliability, performance, and supportability, leading to a superior user experience and increased customer satisfaction. Reduce development costs. Identifying and addressing potential issues early in the development process through a structured approach like FURPS can significantly reduce costly rework, delays, and maintenance efforts in the long run. Enhanced collaboration. FURPS provides a common language and framework for communication among stakeholders. including developers, testers, project managers, and clients, fostering better understanding and collaboration throughout the development lifecycle. Increased customer satisfaction software developed using the FURP model is more likely to meet user expectations in terms of functionality, usability, reliability, performance, and supportability, leading to increased customer satisfaction, loyalty, and positive word-of-mouth referrals. Competitive advantage. Delivering high-quality software that excels in all aspects of FURP can provide a significant competitive advantage in today's competitive market, attracting new customers, retaining existing ones, and establishing a strong brand reputation. By adopting the FURP model, software development teams can establish a solid foundation for building successful software products that meet user needs, exceed expectations, and stand the test of time. The investment in implementing FURPs early in the development process yields substantial returns in terms of improved software quality, reduced costs, enhanced collaboration, increased customer satisfaction, and a stronger competitive edge. In conclusion, the FURP model provides a comprehensive and holistic approach to software quality assurance by focusing on the 5 key components: functionality, usability, reliability, performance, and supportability. Development teams can create software that not only meets but exceeds user expectations. FURP acts as a guide throughout the development lifecycle, helping teams prioritize essential aspects, identify potential issues early on, and deliver exceptional products that stand the test of time. The benefits of implementing FURPs are undeniable. From improved software quality and reduced development costs to enhanced collaboration and increased customer satisfaction, the FURP model empowers development teams to create superior software solutions that drive business success. By embracing the principles of FURPs, organizations can establish a culture of quality, fostering a development environment where excellence becomes the norm rather than the exception. The FURP model provides a proven framework for achieving this quality, ensuring software is not only functional but also usable, reliable, performant, and supportable. By prioritizing these key aspects, development teams can create software that empowers users, drives innovation, and shapes the future of technology. The FURP model is not merely a set of guidelines, it's a commitment to excellence, a testament to the pursuit of building software that truly makes a difference.